All right, so back to practice set 5. We've already worked out these 4 from slide 2. We've done 3 from slide 3. These 3 we just finished up from slide 4. And now we're going to look at balancing reactions with slide 5. And so here we're asked to balance each of the following reactions. In the videos I use tables. So here I'm not going to use tables, but you can always recreate the table based on what I'm going to do for you here. So the way I typically do this when I'm looking at a reaction without a table, I just start with the aluminum sulfate, sulfuric acid going to aluminum sulfate and producing hydrogen gas. So right away I see I need 2 aluminums, but the aluminum here is by itself. So a lot of times what I'm going to do is go after that sulfate. Here I see the sulfates didn't break apart, so I'm going to throw a 3 in front of the H2SO4, and that's going to account for the 3 sulfates I needed to make the aluminum sulfate. That's going to then generate the 6 hydrogens. Well, over here I got hydrogens paired up as H2, so I'm also going to put a 3 in front of that. And now since the aluminum is by itself, I can see nothing else is affected, and now I'm going to put a 2 in front of the aluminum. And then of course, one of the things we always want to do is after we think we have it balanced, so we have 2, 3, 1, 3, I then want to make sure that it's balanced. So here I have 2 aluminums, 3 times 2 gives me 6 hydrogen. There's no hydrogen at all in the aluminum sulfate. 3 times 2 gives me 6 hydrogen. And then 3 times the sulfate, 3 times sulfate, and there's no sulfates here. So that reaction should be balanced. All right, moving on to part B. We have Fe2O3 plus carbon goes to Fe solid plus CO gas. So right away I see I have 2 irons here, which means I should be able to just throw a 2 right there. But I'm going to probably get myself into some trouble here because that's going to be 3 oxygens. I'm going to throw a 3 here. It's going to be my 3 oxygens, but generate 3 carbons. And then I'll get 3 carbons there. And it looks like it might have worked out. Let's just double check it. We have 2 irons, 2 irons, 3 oxygen. 3 times 1 is 3 oxygen, 3 carbon, and 3 times 1, also 3 carbon. So it worked out. All right. And our last one here, part C, the first thing I want to notice is I see a polyatomic right away. So there's my NO3. So I have a nitrate. So I'm going to go to this side and see, did nitrate break apart? It did not. So I have 3 nitrates on this side, only 1 on this side. So I'm going to go ahead and put a 3 in front of that silver nitrate. All right. Then I have 3 chlorines. So I'm going to throw a 3 in front of the 3 silver chlorides. It looks like that's going to work out for me. I have 3 silvers here and 3 silvers there. Only 1 aluminum here and 1 aluminum there. So it looks like we might be balanced with a 3, 1, 3, 1. But let's go ahead and give it a try. So we have 3 silvers, 3 silvers, 3 nitrates, 3 nitrates, 1 aluminum, 1 aluminum, 3 chlorines, and then 3 times 1 gives me 3 chlorines. So there we are. Those 3 reactions are balanced. Since we just balanced reactions, I'm going to go ahead and move on to the next one because I think here we're going to be doing the same thing. So we're actually going to get both of these slides into this one video, I believe. So here what we're doing is completing the reaction and then balancing. So first we want to determine the type. So we have a single metal here and then a compound. That means we're going to have a single replacement. So the zinc then is going to replace one of the elements in the HCl. So zinc is a metal. We know we write metals first, which means it's going to knock out the hydrogen. So we're going to get Zn Cl plus H. So now, just going to do a little bit of cleaning here. We know that the zinc is a transition metal, but it is one of our exceptions. We know it's a +2. The chlorine here is a -1. It's in group 7A. And the hydrogen, of course, by itself, we have to remember the rule that there are 7 elements that are always diatomic. And actually it's 8, but we really only look at 7 of them. So it's H2, 1 + 7 rule. And then, of course, since hydrogen is the 1, that means it's diatomic. Now back over here, we're going to use those charges to balance. And so we can see that we have a +2 for zinc, a -1 for Cl. We can crisscross those. And so we get ZnCl2 plus H2. Now remember, zinc is a rule that it's always +2. Silver is always +1, and cadmium is always +2. If you look at your naming flow chart on how to name compounds, I actually put that in there with your transition metals for, reminder's sake. If you're reading through that, you can see it in the one box. All right, that was determining the type. We said was single replacement. So SREP we just completed the reaction based on that. And now at last we want to balance it. And so I have 1 zinc, 1 zinc. I have 2 chlorines here, so I'm going to need a 2 in front of the HCl to get 2 chlorines. That's going to give me 2 hydrogens, but that's okay because I have H2 gas. All right, that one looks like it's going to be good to go. All right, so here we have aluminum as a solid plus bromine liquid. When it reacts, it's going to form AlBr. All right. Now we know this is going to be element plus element, which means this has to be a combination. So a combo, which means I'm going to put those 2 elements together just like I did. And now I'm going to look at charges. So if I go to my periodic table, I know the aluminum is a +3 because it's in group 3A. The bromine is a -1 because it's in group 7A. I can crisscross those and get AlBr3. Okay, now I need to balance the reaction. Right away I notice I have an even number for bromines because it's diatomic, and I have an odd number for bromines in the product side. So I have to make those 2 meet, and the way I'm going to do that is by multiplying them together. So I'm going to get 2 times 3 is going to give me 6. 6 is going to be the common factor between these 2. So I'm going to put a 2 in front of my aluminum bromide. I'm going to put a 3 in front of the bromine, and now I'm just going to fix that aluminum. 2 times 1 gives me 2 aluminum. So I get 2 aluminum, 3 times 2 gives me 6 bromine, 2 times 3, 6 bromine. All right, last but not least here, we have nickel chloride plus sodium hydroxide, compound plus compound. That means this is going to be a double replacement, so a D-rep. Here I'm going to let the metals change places, right? Because metals replace metals, nonmetals replace nonmetals. So my products then are going to be sodium is now going to be with the chlorine. And I'm not going to worry about how many of each one is there just yet. I'm just going to get the partners together here. And then the nickel is now going to be with the hydroxide. So Ni is going to go with the OH. I'm going to put OH in parentheses because it is a polyatomic. I want to make sure I'm moving it across as a unit. All right, now to get subscripts, we have sodium is a +1. It's in group 1A. Chlorine's a -1 in group 7A. Crisscross those, and that's 1 to 1. The nickel here is a transition metal. So really what I have to do is go back here and look, and the chlorine being a -1, but there's 2 of them, means the nickel had to be a +2. So I'm going to leave the nickel as a +2. Its charge shouldn't change. It's just exchanging with the sodium. Then again, I'll look at my hydroxide on my polyatomic list is a -1. I'll crisscross those, and now I'm going to move that 2 to the outside of the parenthesis. All right, so that's our double replacement reaction. Last thing we need to do then is balance. So I have 1 nickel, 2 chlorines. So I'm going to put a 2 in front of the sodium chloride. That gives me 2 chlorines. I'm now going to have 2 sodium. So let me put a 2 in front of the sodium hydroxide. And that's going to give me 2 hydroxides, which I already have. So this reaction should also be balanced. All right, so that took care of slides 5 and 6 from this problem set.